Okay, we have another astronomical mystery we have to discuss, but this time there is possibly a solution. And that's basically what this video is going to be about. It's about a mystery that researchers discovered a few years ago that has now been potentially solved. And in this case, it's a mystery in regards to very unusual signals coming from certain objects out there. And what you're seeing here is one of these signals. And so, hello wonderful person, this is Anton. Let's discuss exactly what these new studies are about, and what sort of a mystery this solves, and of course discuss how these very strange signals seem to form. And by the way, you can find some of the previous videos and some of the previous studies about this in the description below. But in essence, this is in regards to a detection of very strange and very slow signals from across the Milky Way galaxy. Now, just so that we're clear, these are natural signals, not aliens and not extraterrestrial intelligence, but even for natural signals, they actually did not make much sense, with some studies even claiming that they should not be physically possible. And the reason these signals seem to be so unusual is because they essentially looked very different from what we usually see from a lot of these dead stars. So things like, for example, neutron stars and white dwarfs, because normally they're the ones producing most of these radio signals and even X-ray signals across the galaxy. They're the only ones that are powerful enough and contain just the right ingredients to produce very powerful radio emissions. But even though astronomers thought we understood these stars pretty well, in the last few years researchers discovered a few surprises. And the funny thing, it was only discovered because scientists decided to look at some of the older data and basically refine their search, focusing on some of the longer signals as opposed to shorter ones, which has never really been done before because researchers believed that longer signals should not be possible. And so basically, to understand this mystery, we have to briefly discuss pulsars and radio emissions. Now, in the majority of cases, pulsars are neutron stars, and in this case neutron stars that spin very fast. Some of them spin several hundred times per second, which is why they produce frequencies of hundreds of hertz. And you can learn about some of the fastest spinning pulsars we discovered recently in one of the videos in the description. And in pretty much every case, they emit radio beams just like some kind of a lighthouse. But when it comes to these objects, there is a kind of a limit, also known as the death line. Or basically, if they start spinning really slow, they suddenly lose all of this rotational energy and lose their ability to produce radio waves or X-ray emissions until something accelerates their rotation once again, such as, for example, consuming a lot of mass from their partner. This actually has been observed several times. But then in 2022 and further in 2023, astronomers discovered something that really didn't fit. They found objects like GPM J1839-10 that was emitting powerful signals, but with an extremely long period, 21 to 22 minutes. But even more shockingly, when scientists looked at some of the archival data, they discovered that this object was doing this since at least 1988 when the observations began, which means that it was probably doing this much longer. And for a lone neutron star, or even some kind of a magnetar, this should not be possible, assuming our physical models are correct. With such a slow rotation period of 21 minutes, it should not be able to produce these powerful radio emissions. And so the discovery of this object led astronomers to re-examine some of the data, discovering other similar objects, or these very strange slow pulsars, that have now created a kind of a new category that doesn't really make sense. These are now known as long-period radio transients, also known as LPTs. A new class of objects characterized by powerful radio emissions that are usually extremely polarized, or basically come from very magnetized sources, but are usually very slow, with pulses lasting for 10 to 100 seconds and usually happening every few minutes. And while up until recently, or up until these recent studies, it was assumed to be some kind of a very strange magnetar and potentially some kind of a very bizarre neutron star with very powerful magnetic fields, but just spinning super slowly. But the problem with that explanation was that, well, we've never really seen these objects before, and there was no explanation for how they could form or for what exactly made them produce such powerful emissions. But that's essentially what this new study tries to explain. In a very recent study led by Csanád, Horváth, and Natasha Hurley-Walker, and my apologies to you for most likely mispronouncing your names, has now given us a massive clue. Here, by basically using some of the most powerful radio telescopes we have right now, the Meerkat telescope, ASCAP, and the Very Large Array, researchers were able to track this particular object for 36 hours straight. And what they've discovered now kind of changes the entire story entirely. One of the most important discoveries here was a kind of a high-order periodicity. basically meaning that the pulses are not random, but seem to cluster every 8.75 hours. And this 8.75-hour cycle is almost certainly an orbital period, meaning that this mysterious signal is not coming from some kind of a mysterious magnetar, but seems to be coming from a binary system, two stars dancing around each other. With the new model essentially suggesting that this is a system made out of a white dwarf and some kind of a low-mass companion, very likely an M dwarf, or basically a red dwarf star. And here this is important because white dwarfs are usually much larger and have more rotational energy than a typical neutron star. But they also generally spin much slower. Yet despite of this slow spin, they can still produce radio waves too, and in some cases be quite powerful. Okay, but how exactly would they do this? And how exactly are they able to produce these very powerful radio emissions visible from 15,000 light years away from us? Well, here we have a visual representation produced by the scientists. So here's an example of a regular pulsar that will usually produce emissions from two separate poles. But in this particular situation, it seems to resemble this. We have a pulsating white dwarf and a red dwarf extremely close to it. And the reason this white dwarf is pulsating is because it seems to contain a very strong magnetic field that is potentially slightly tilted. But as the white dwarf rotates, its magnetic axes occasionally sweep across the wind of particles being blown off from the companion M dwarf star. And when the emissions from the magnetic field interact with these particles, they suddenly get accelerated to nearly the speed of light, creating an extremely narrow and very powerful radio beam. But the reason we see the pulse is because, in this case, the white dwarf's pole, Earth, and the companion star align in just the right way. And so here this is just a lucky alignment that then allows us to see the emissions. And so in this study, researchers found that radio pulsars seem to be triggered specifically when the white dwarf's magnetic axis intersects the companion's wind inside the orbital plane, which is what you see simulated in this case. But the thing is, this particular simulation is from a different system. As a matter of fact, this particular explanation and this discovery actually links another mystery from over a decade ago. A rare group of objects referred to as white dwarf pulsars, with the most famous being right here, AR Scorpii. This object was discovered to be a white dwarf pulsar back in 2016. And so here we also have a white dwarf orbiting a red dwarf, but in this case with a slightly shorter orbit of 3.5 hours, with scientists eventually realizing that this 2-minute pulse is actually a beat period, a result of the interaction between the white dwarf spin and the orbital motion. And naturally this is not the only such system known to us. Another similar object known as J1912-4410 was also discovered a few years back with an extremely similar emission profile. The orbit is about 4 hours long, with a pulse lasting for 5.3 minutes. And so by studying these objects, researchers discovered that there is definitely a pattern. These are not just accidents, they seem to represent a specific stage in stellar evolution where a white dwarf is suddenly spun up, very likely because of the interaction with its companion, and then suddenly develops a very powerful magnetic field that starts to interact with its companion's stellar emissions and result in powerful radio signals. But the main reason it took so long to finally discover this and to finally explain this is because of where these objects are located. Most of these unusual LPTs, or long-period transients, seem to be inside the center of the galaxy. And when we look at this region through a typical optical telescope, because there are so many stars here, it's actually super difficult to tell which one of them is emitting these radio signals. And so it wasn't until recently that scientists finally figured out exactly where the signal is from. But not all of them seem to be in the center. At least one of these transients, Glimax J0704-37, was discovered on the outskirts of the galaxy, away from everything else. And so in this case, because there were so few stars around it, researchers were finally able to pinpoint the exact location. And so here, by confirming that this was a low-mass red dwarf in a binary system with a white dwarf, it finally gave researchers enough data to start making conclusions and to start creating models. And so in this case, this system was a kind of a breakthrough needed to prove that these slow signals seem to be coming from binary systems. And so for astronomers, this confirmation and these additional discoveries are actually quite important. Because first of all, this explains these signals not as some unusual impossible magnetars, but as systems we've known existed for quite some time now. And so if these are all white dwarf binaries, it helps us understand the evolution of magnetic fields on top of explaining what happens in these systems. However, if one of these objects is a magnetar, it might challenge our understanding of neutron star physics, because trying to explain very slow-moving magnetars with very powerful magnetic fields is super challenging. And so this elegant white dwarf explanation right now makes the most sense. And it also tells us just a little bit more about white dwarf evolution. For example, one theory referred to as crystallization-driven dynamo suggests that as white dwarfs cool down, and as their core begins to freeze and to crystallize, it generally starts to create massive magnetic fields. And this is very likely what's happening here. So basically this is just an aging white dwarf that suddenly acquired a powerful magnetic field that then interacts with its partner. In other words, this actually connects quite a few different propositions in one single explanation, while also providing us with a perfect example for the beauty of modern astronomy. What basically started as these mysterious unexplained signals from just a few years ago, and signals that kind of seem to break physics, are now explained very well by connecting them to individual propositions involving white dwarfs and even very well-known stars like AI Scorpii. Which means that we officially now have another type of a pulsating object to add to the list of radio signals across the Milky Way, a white dwarf pulsar. A type of an object that's able to produce very bizarre and very long signals that seem to resemble a slow-motion pulsar because of their pulsations lasting minutes. But at least for now, that's all we know. It was actually kind of exciting to follow the progress here, from the original discovery that you can learn about in the description below to the final conclusion, or the final explanation. But naturally, there might be some additional explanations, especially if scientists discover something else. And so until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining the channel membership that grants you early access and a few additional things. You can also buy the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.